know how to calculate basic probability if all the outcomes in a sample space are equally likely, right? So the idea here is if we're interested in finding the probability that some event A happens and all the outcomes are equally likely, we just count the number of outcomes in event A, okay, the number of outcomes we're interested in, and we divide by the total number of outcomes possible in the sample space, right? Graphically, we might think about this as, hey, we got this sample space S here, and let's say this is A over here. And so we just count all the outcomes that are in here and divide it by all the total outcomes possible, right? But what if we have additional information? That could change the probability. For example, initially, what if we know that generally in California it rains, 5% of the time? Well, if I tell you, and we want to know the probability that it rains today. Well, if I give you additional information and tell you that it actually is incredibly cloudy today and dark gray clouds, that might change the likelihood that you assign to whether or not it's going to rain today, right? That seems like it's more likely to rain today than just our original probability would indicate. That additional information changed for us the probability that it was going to rain, okay? So what happens if we have additional information? Say that, let me change the color here. Say that instead of just knowing that sample space S happens, say we know that B has already happened, okay? So we can limit what the possibilities are. Now, it's not all the sample space that is possible, right? Now it's only this that's possible, okay? So we call this conditional probability. We're finding the probability given some other condition that we are already know or already assuming to be true, okay? And we write it probability of A given B. We want to know the probability that A happens given this vertical line means given that B has already happened, or we already know B is true, okay? So how does that change how we calculate the probability? Well, the central idea is the same. We want to take all the outcomes that we're interested in and divide by all the outcomes that are possible. But now, because we have this extra information, what outcomes are possible has changed, right? So it's no longer all the outcomes in the sample space that are possible. Now, because we know B is true, only the outcomes in event B are possible. So instead of dividing by the number of outcomes in S, we divide by the number of outcomes in B, because those are the only outcomes, based on what we now know, that are possible, okay? And in the numerator, we want to count the number of outcomes that we are interested in, okay? The number of outcomes that we're interested in. That's no longer all the outcomes in event A, okay? Because there's a lot of outcomes in event A that are no longer possible. Only these outcomes in event A are still possible, okay? Now that should look familiar. We just talked about that. These outcomes here are in event A and B. So instead of finding all the outcomes in A, we want to just count the outcomes that are in A and in B, okay? So this is the formula that we use to calculate conditional probability if all the outcomes in the probability space are equally likely. If all outcomes are equally likely, this is the formula, okay? Now, there is actually a more general formula that we use, and we'll use it later on. For in this section, for the problems we're going to cover here, we'll mostly be using this formula. But just so you know that there is a general formula for conditional probability that we will need to consider in the future. And it's similar, but it takes into account not just the number of outcomes, but the likelihood of those outcomes. So instead of just counting up the number of outcomes in A and B, we count the probability that A and B happens. Instead of just counting the number of outcomes in event B, we calculate the probability that event B happens. Okay, so that's the general formula. This formula is just a special case of this more general formula. But this formula is conditional probability when all outcomes are equally likely. And again, for this section, we will be primarily using this formula. Eventually, there will be times where we will need to reference this more general formula. But for now, we're going to focus on this formula.